Hi everybody. We're going to work exercise number 19 on page 53. When I first read this, I really didn't see how false position applied. But we're going to take a close look at it, and we're going to work through it a few ways. The problem essentially addresses the division of 6, 7, 8, and 9 loaves equally among 10 men. And they tell us to solve this by false position, expressing our answer in unit fractions. So let's start. We'll let x be the number of loaves that each man gets. So each man gets the same amount. Each man gets X loaves of bread. So let's see how this works out. We have 10 men. Times X loaves per man, and men cancel, and that's supposed to give us 6 loaves. Let's do this for the case with 6 loaves. The other cases will be the same, except how we express the final answer in terms of unit fractions. So we're going to take 6 loaves and divide them among 10 men. X is the number of loaves each man gets. So we have 10 men times X number of loaves per man. The men cancel out, and we have 10x loaves equals 6 loaves. So this is what we have. 10x equals 6, or 10x minus 6 is equal to 0. Now I look at this and I say, I don't really see how we solve an equation like this by false position. I can see how we could perhaps rewrite this equation and solve it by double false position. So let me try it one more time. I'll write it this way: 10x plus a minus 6 equals 0. And you see, I have it in the form now of ax plus b equals 0, which is exactly the form that we want an equation to be in if we solve it by double false position. And at this point, it looks like this exercise is more easily solved by double false position. So let me do this. By double false position, and you remember how it is that we do this. We have 2 guesses as to what the solution x is going to be. I'll let G1 be my first guess, and it always seems as though 0 is a good guess. And pick something simple for the second guess. I'm going to guess G2 equals 1 for the second guess. And my only motive there is that if I take 0 and plug it into that equation for x, it's going to simplify to -6. If I take 1 and plug it in here, it gives us 4. So G1 equals 0 and G2 equal 1. They're just easy to work with. That's my only motivation. Now remember, F1 is what the right-hand side becomes if I plug in G1 for x. So F1 will be 10 times 0 plus -6, which equals -6. F2 is what the left side of the equation becomes if we plug in G2 for x. So I'll plug in G2 equals 1 for x. And I get F2 is equal to 4. And then we remember this completely and totally serendipitous outcome. X is equal to F1 G2 minus F2 G1 all over F1 minus F2. So let's see what happens. Plug in F1, we get -6 times G2 is 1. Plug in F2, that is 4, times G1, that's 0, all over F1 minus F2, and I get -6 over -10, which equals 3/5. And that would be our answer if they hadn't told us to express this as the sum of unit fractions. So we'll continue this down here. I'll take 3/5 and write it as 1/5 plus 2/5. And from the table on page 40 of our text, the splitting formulas, they have 2/5 decomposed as 1/3 plus 1/15. 1/3 plus 1/15, which equals, if we set them up in descending order, 1/3 plus 1/5 plus 1/15. Solved using double false position. Now, they did tell us in the instructions to do this by false position. And I'm really not sure if that's the way they wanted to do it, or if this was maybe some kind of a mistake. So let's try this by false position. The original equation, the one that we didn't really like all that much when we saw it, and so we immediately rewrote it. Or maybe I wouldn't include you with, or I shouldn't include you in something that I did and decided all by myself. The original equation, 10x equals 6. And I look at this and I say, how are we going to do this by false position? False position, and I'm going to be very loose with my jargon here, solves equations of the form time to move over, solves equations of the form x plus b over ax equals c. And of course we looked at 10x equals 6, and we say, wait a minute, there's only one term here, and there's no fractional coefficient. But let's just stretch things a little bit. I have no problem letting 6 be our c, and maybe we can take 10x and decompose it into x plus something else. 10x, I can write that as x plus, well, I don't have any other choice, I'll say 9x equals c. And this is supposed to be of the form b over ax right here. Okay, well, if they insist, I'll write it this way. 9 over 1x equals c. Now, our next step in the method of false position is to plug in an x value that will eliminate fractions. Well, the x value that we plug in here, as long as it's a whole number, there are going to be no fractions. What the heck, let's pick something 0. Let's say x equal 1. And we plug that in, and we get 1 plus 9 over 1x equals 10. But the right-hand side should be 6. So what are we going to do? We multiply both sides by 6/10 to make the right-hand side equal to 6. Six-tenths times 10. That's so easy, even I can do it. And now I'm going to distribute this 6/10 inside the parentheses so that the left-hand side retains its original structure. Something plus 9 times that something. Remember, that's what we had. Something plus 9 times that something. So I'm going to have 6/10 plus 9 times 6/10 is equal to 6. And right here is our x. X equals 6/10, which equals 3/5. And this decomposes, as we saw originally when we did it in double false position, as 1/3 plus 1/5 plus 1/10. Okay, so we've done 19 by false position and double false position.